Howdy class, how's it going? We got a 7.2 here. So this is running full hypothesis tests. And this is for the mean. So we're going to be using the Z distribution for these. You do a hypothesis test in 6 steps. And so right at the top of page 4 in your notes, we have the steps. We've done pieces of that in 7.1. So number 1 we've done. Number 2 is a verification thing. Number 3 is actually from chapter 5. We got to calculate a z-score. Then number 4 is also from chapter 5. Convert that z to an area under the standard normal distribution. So really we've done 3 and 4 already. And then 5 and 6 we did in 7.1. So we've done all this in bits and pieces. Now we're putting it all together. So to review, first thing is, how do you calculate a p-value once you know that z? Okay, so in step 3 above, you find that z-score. And then you're going to have to convert it to a p-value. And so there's some instructions there. You can use the standard normal distribution table, or you can use StatCrunch. I'll go through both. So those 3 bullet points depend on the type of test: left tail, right tail, or two tail. Right? So left tail, you just look it up in the table. Right tail, you look it up and then subtract from 1. Feels familiar. Two tail is a little new. Two tail, you're going to find that p-value and then multiply by 2. So let's practice with that a little bit. I'm going to run through these 4 examples using the table. So let's look at that first one. Z is negative 1.45, and it's a left-tailed test. All right, let me bring my table up. And you're just going to look that number up in the standard normal table. Let's see, where's my table? There it is. Negative 1.45. There it is. 0.0735. And since it's a left-tailed test, that's it, right? So it's just that number, okay? For number 2, it's 2.09, and it's a right tail, right? So for a positive z-score, 2.09, there's 2.0 over here to 9. Looks like 0.9817. But since it's a right tail, you're going to take that 0.9817 and subtract it from 1, which would give you 0.0183. That's it. All right. For number 3, z is negative 0.98. So I go look up negative 0.98. It looks like 0.1635. So I start with that 0.1635, but then I have to multiply that by 2. So I'm doing 2 times 0.1635, which would be 0.327. Okay. So that's those are your real basic 3 examples: left tail, right tail, or two tail. It's always one of those tests. Now the one that's a little weird and tricky is number 4, because it's a positive z-score and it's a two-tailed test. If you think about that, positive z-scores are on this page, and they're all already greater than 50% or greater than 0.5. You times any of those numbers by 2, it's going to be larger than 1, which doesn't make any sense for a probability. Probability is always less than 1. So to fix that, if you have a positive z-score and a two-tailed test, actually look up the negative of the z-score and times that by 2. So for number 4, it's positive 1.62. I'm actually looking up negative 1.62, which would be this row. Negative 1.62 is 0.0526. and then times that by 2. And that will be your p-value, okay? So I'm going 2 times 0.0526. That will be 0.1052, all right? So that's the tricky one. All of those can be done with StatCrunch too. If I want to look at the StatCrunch way, if you prefer, I don't care which way you do it, table or StatCrunch. Either one's fine. So I'll show the StatCrunch as well. It's that stat calculator normal that we've gone to in chapter 5. Right, so that's a familiar calculator. Leave the means 0 and 1. And we were given z-scores, so that first one, if it's a left-tailed test, negative 1.45, there it is, right? For a right-tailed test, I would just flip it around, greater than 2.09, 0.0183, which is what we got with the table. For a two-tailed test, I'm still going to do that times 2 thing. So I get the 1 tail, right? And then I'm just going to take that number and times it by 2 for a 2-tailed test, okay? And then that last one, the one that's kind of tricky, the 1.62. Since it's on the right, I'm going to go greater than, so I get that right tail, and then times that number by 2. All right. So those are my 4 examples using StatCrunch. Okay. And we got Nora Jones. Let's close out Nora Jones there. Okay. Let's go back to the handout. And I wrote those answers down. If you're following along, you probably did too. Just to summarize that. Again, there's basically 4 scenarios here. Right, left tail is the basic one. Right tail, subtract from 1. Unless you're using StatCrunch, you don't subtract from 1. Just use the greater than symbol in StatCrunch. For a 2-tail, if it's a negative, be on the left side, times it by 2. And if it's a positive, you're on the right side, times it by 2. Okay, those are your scenarios. Let's now run a full test. Let's see if we can put it all together. Okay. Suppose you are using a 5% level of significance to test the claim that mu is greater than 13. And then you've got your sample statistics. So step 1, if I look at my handout there, I want to state my H sub 0 and H sub A. All right. Mu greater than 13, since it does not contain equality, will be an HA. And that is the claim. All right. H sub 0 is just the opposite. The type of test is always based off of the HA. Right, so I'm looking at this symbol right here for deciding the type of test. And since it's a greater than symbol, it's a right-tailed test. Those are all the things I want to write down for step 1. Right. Step 2 is really just a verification that allows you to use the test. You just have to verify that n is at least 30, which we do have in this case. N is 50, so we're good there. Or if n is less than 30, somewhere in the wording it has to say that the population is normally distributed. Okay, so there's really no work to do with that number 2, it's just verification. Number 3, step 3, is finding that z-score with the formula. So if I follow along that formula above, that says do x bar 13.3 minus mu. Where you get mu is always from your hypotheses. So we're using that 13 from hypotheses. In the bottom, we have sigma 1.2 divided by square root of n, which is 50. Okay. I'm now going to calculate that. That's approximately, if I do 2 decimal places, 1.77. And there's my z. That's step 3. Step 4, change that into a p-value, just like we practiced. So this is a right tail test, and z is 1.77. I would pull out the table or use StatCrunch to look up that p-value. I'm going to do the table way. So 1.77, I'm looking it up on my table, is 0.9616. So my p-value is going to be 1 minus 0.9616. Because it's a right tail test and I'm using the table, I've got to do the 1 minus. That calculates out to be 0.384. Again, the interpretation of this value is the probability that you would see these sample statistics if you assume the null hypothesis is true. So it's kind of low, right? Only a 3% chance of seeing these sample statistics, which probably means that that original claim is not true. Because it's not that, this will be an unusual sample if that's true. Okay, so that's what we're trying to decide now, and come up with this conclusion. So that's when I'm doing step 5. Okay, so on step 5, I'm comparing P to alpha. Notice here that P is smaller. You got like 3% compared to 5%, right? P is smaller than alpha. Anytime P is smaller than alpha, that's always reject H sub 0. Just as it states in the directions there. So I'm going to reject H sub 0 in this test. If P was bigger, then you fail to reject H sub 0. It's always H sub 0 in that. It's either you have two things that are going to happen here. Reject H sub 0 or fail to reject H sub 0, and that's it. Now, finally, we're putting it all together to make a final conclusion. And that is based off of two things. The fact that HA is the claim, and we rejected H sub 0. So then you can go to your conclusion table and see what that leads to. What is the sentence that says? Right? So in my final conclusion, there is sufficient or enough evidence to support the claim. And that's really the answer to this question. So those are the 6 steps. Hopefully that makes a little bit of sense. The more you do these, the more repetition you'll see, and they become easier and easier as you go along. We'll be doing this type of problem in chapters 7 and 8, so you'll see a lot of them. So I'm going to end there, and I'll continue with some more examples in the next video on page 5. But you might want to try those on your own, and then check out the video to see if you're right. Okay, hope all is well. I'll talk to you soon. Thanks. Bye.